So students, your NEET exam is coming up in May. So in this series we will discuss some of the previous year questions, important questions from different chapters. Today we have taken similar one questions from your previous year NEET from your mechanical properties of liquid chapter, and some relation also will establish with the your Boyle's law. So here the question is that one bubble is there in a lake. This is, let's say, lake of depth d. This is the lake of depth d, and a bubble is there at the bottom of the lake. This is the bubble, and this bubble will rise, go up, and when it will reach the surface, till it reaches the surface, its radius will become double. That means initial radius is, let's say, r. When it will reach, the radius will become 2r, right? So you can, let me bring a little bit closer so things will become clear to you, right? So here the radius is increasing. So when the radius is increasing, definitely you can think of, because as we go more depth to the lake or sea, so the pressure will increase. So that's why the sphere also volume will shrink, decrease, and as we pressure is less, so maybe the volume will, here the volume will increase. So the question is that the pressure on this one at the surface is equivalent to a pressure on a column, of height h, pressure of column of water of height h equal to the pressure. So this is equal to a column of water of height h, right? So the pressure on the surface. So this is the pressure. So we can write the atmospheric pressure is given. So atmospheric pressure we can write, this is a column of height h. So the rho pressure, atmospheric pressure is rho gh. We can write rho gh, right? So this is your pressure. Now here what we'll do, you can see that the volume is increasing. So what we can write is that the initial volume 4 by 3, it's a sphere, pi r cube, and the final volume is 4 by 3 pi 2 r cube. This is, let's say, v, this is bottom, and this is v surface, volume of the bubble at the surface, right? So this is what the volume of bubble bottom and surface. So Boyle's law, if we will use here, we can say that pressure and volume is a constant. Pressure and volume is your constant. So because you can say that temperature is uniform, and there is a constant, you can say here bottom and top same temperature is there. So for constant temperature, Pv equal to mu RT or nRT, so nRT is a constant. So pressure and volume is a constant as per the Boyle's law. So here we can say from this condition, if we'll say, then we can say that your pressure into volume, so pressure at the bottom into volume at the bottom is equal to pressure at the surface and volume at the surface. This equation will be valid. Now pressure at the bottom, what will be the pressure at the bottom? Now we know that the variation of pressure with depth. So variation of the pressure, let's say, is depth, pressure depth equal to pressure at the surface, which will be definitely atmospheric pressure, because at the top pressure at the surface plus this rho density g into d depth. So this is the pressure at the depth d. So if we use here the pressure at surface plus rho g depth into volume of b. So volume at the bottom is 4 by 3 pi r cube equal to pressure at the surface, that is basically atmospheric pressure, and we can simply write PS, then later on we will use this one only. Atmospheric pressure already told that it is equal to the pressure of a column of water height h. So PS and Vs, volume at the surface, is 4 by 3 pi 2 r cube. So basically 4 by 3 pi cancelled out, r cube cancelled out, 2q is there 8. So basically we can say 8 ps, and left side we can say that ps plus rho gd, right? So ps is equal to this one, rho ps equal to rho gh. So you can say rho gd equal to 8 ps minus ps, pressure at surface, that is your atmospheric pressure basically. So this is your 7 ps, that is rho gd. So rho gd is 7 ps and ps is your rho gh. So this is your rho gh. So basically your 7 rho gh. So rho g cancelled out. Density of the water, this is given that this is the column of water actually, means lake is also having water and this column is having water only. So this is having water only. So you can say density, both this row and this row same actually. This row and the lake water also, this is a water lake of water. So this row and this row are same. So rho cancelled out, gg cancelled out. So basically we can show here that your depth d equal to 7h. This one is the surface. Pa means, so ps means pressure at the surface. So that is your atmospheric pressure only. So if we will replace this one with rho gh, capital H, because it's given that it is equal to the pressure of a column of water of height h. That means indirectly it's given that the pressure of this one is rho gh. So basically if we will cancel out, so answer will be your 7h. The options were given in this question: h, 2h, 7h and 8h. The options were given h and h, 2h, 7h and h, 2h and 7h and 8h. So 7 is the correct answer. Now this one is your PYQ from NEET. Now similar one we will discuss in the coming videos. So here we use two concepts basically. If you look carefully, one is Boyle's law we have used, that how pressure and volume is playing a role here, because the volume is increasing as it is going up, right? So this one is another one law. Second law we are using this one, the variation of pressure with depth. As will go deeper and deeper, the pressure will increase, and it will increase from the surface, the point where we are calculating from the surface, plus rho gd. This pressure difference also we call it your gauge pressure difference. So these concepts we are using, two concepts here we are using. So thank you, see you in the next video.